normal, but this is bending towards the normal. So this option is incorrect. For the second option, the light ray is coming from air to glass, and air is rarer, glass is denser. So this is going away from the normal. This is also incorrect. It should go towards the normal. This glass and water. So glass with respect to water is a denser. Glass is denser and water is rarer. So this ray after refraction bend away from the normal. So this option is also incorrect. Let's check this. This is glass denser to rarer. So denser to rarer means this light ray moves away from the normal. So this is also incorrect. So here you can see that here is water and glass. So this option is correct. See this, the light ray is bending towards the normal. Actual path of light ray is this, and this is bending towards the normal. So now this question. A vertical ray of light strikes on the horizontal surface of some water. Means horizontal surface of water. This is a water surface. And a ray of light is coming vertically like this. And what is the angle of incidence? 0 degree. Because the ray of light here is coming along the normal. So angle of incidence is 0. So this light ray will move like this because angle of refraction will also be 0. We have discussed this. Earlier we have discussed this. So let's come to our topic, refractive index. So I have told you what is the refractive index, and we will represent refractive index by small n. So refractive index of a medium is given by sin I by sin r only when the light ray is traveling from air to any other medium. And we have done one question also. Now there are some other definitions or other formulas of refractive index. So refractive index we will represent refractive index by small n, and refractive index is defined in by two ways. Number one, absolute, and I will write this refractive index in short Ri. Ri means refractive index. Absolute refractive index and relative refractive index. Relative refractive index. Absolute refractive index is defined when a light ray is traveling from air to any medium. This is defined when light ray traveling from air to any medium, and this is represented by air to medium. This is small n. You will write absolute refractive index as like this, or you can write this simply refractive index of medium. Relative refractive index is defined when there is a two medium other than air. When This is defined when light is traveling from one medium to another. So this is defined when light ray traveling from one medium to another. And you can say here air or vacuum also. Vacuum means free space. Vacuum is free space. No particle is present in the space. And this is represented by, suppose the light is traveling from medium 1, light is traveling from medium 1 to medium 2. So you will write this refractive index. Here you will write medium 1, medium 2. So this is known as the refractive index of medium 2 with respect to the, this is known as this 1 and 2 is known as the refractive index of medium 2 with respect to medium 1. And this 1 and 2, 1 and 2 is written as n2 divided by n1 simply. Or this 1 and 2 can be written as 1 divided by n2 1. So Azaan, this is one of the very important topic, and just write it down in your copy in a proper way. Okay, sir. This is one of the most important topic and very confusing also for the student. Actually, for defining the refractive index, we have a pair of medium. Means we have two medium. For single medium, we cannot define the refractive index. For the absolute refractive index, also we require air as a medium or vacuum as a medium. This symbol is very important. This symbol 1 and 2. So this is the refractive index when light traveling from medium 1 to medium 2. This is very important. This topic is little bit confusing. You find this topic confusing little bit. So I request you to focus properly. Very easy topic, but when we define the refractive index, the student gets the confusion in what is the absolute and what is the relative and how to write absolute and how to write relative. So we will solve some numericals, then it will be clear. Azaan, are you getting the motion of my dot?
Yes, sir.
Getting na properly?
Yes.
This is a small n, small n, small n, small n. Written, Azaan?
No, sir. 1 minute.
Okay, all right, no problem.
Done, sir.
Just make 1 star on it.
Okay, sir.
So now, just I am checking whether you have understood or not. So suppose the light ray is traveling from uh, water to glass. Azaan, are you okay with this red color?
Yes, sir. No problem.
So suppose the light is traveling from water to glass. How you will represent the refractive index? First you will write N. The light is traveling from water to glass. So on the left side you will write water. Okay. So this is the, what you will call this, refractive index of glass with respect to water, and this is also equal to refractive index of glass divided by refractive index of water. And this can also be written in this term 1 upon, and this G will go this side and this W will go this side, G and W. It means that this is the refractive index when the light ray is going from glass to water. Okay. So this thing is very, very important. So just note it down and I will give you the time for noting this. Just we will solve one question. So this is the question. Not this. We will do this later. This question. So this is one of the most important question and very confusing also for the students. And we can solve this question in just 30 seconds. Just see this. Just focus on your screen and read the question one time. If the refractive index of water for light going from air to water. So light is going from air to water. Just wait. Okay. So light is going from air to water, So how you will, and they are saying the refractive index of water, they are saying is this. So how you will write the refractive index of water? The meaning of this, they are saying refractive index of water with respect to air is given as 1.33. Now they are saying that what will be the refractive index for light going from water to air? Now this time when the light is going from water to air, water to air. So how you will write the refractive index? Light is going from water to air. This we have to find. So I can write this 1 upon refractive index of A this side, water this side, and this value is given as A 1.33, and you will get the answer 0.75. Azaan, getting?
Yes, sir.
Means this time the light is going from traveling. Light is traveling from air to water, and they are asking the refractive index when the light refractive index for the light going from water to air. So we have just applied this. So in this way also you can solve the problem. One of the easiest ways to solve the problem. We can also solve this problem with the help of speed of light, a relation by using a relation of speed of light with refractive index, but that I will use later. Okay. So if you have any type of confusion, you can ask me.
No doubt.
So then I am just giving you just one question. Suppose this is given refractive index of medium 2 with respect to 3 is given. Medium, this is called as refractive index of medium 3 with respect to medium 2, and this is given as suppose 4. And we have to find refractive index of this we have to find. So just tell me the answer in 30 seconds. Azaan, have you solved this?
Yes, sir.
Uh, what are you doing?
Sir, I am doing it.
This is very easy, na? See, this we have to find. This is small n. 3, 2 we have to find. So I can write this 1 upon small n 2, 3. This 2, 3 is given as 1 by 4. The answer is 1 by 4. This is 0.25. Okay.
Okay.
So now, what happens now? Just listen for 2 or 3 minutes. Just only listen. What happens when light travels from one medium to another? The bending of light takes place. This is known as the refraction of light. And why this refraction of light takes place? Because we know that in different medium, the speed of light is different. But we also know that now refractive index of different medium also different. So with this, we derive a relation between the speed of light in a medium and the refractive index of the medium. Speed of light of a medium and refractive index of a medium. So I have told you that if the medium is denser, then the speed of light is less. Speed of light is less, and the refractive index will be more. So it means that the refractive index of a medium is inversely proportional to the speed of light. Means more the refractive index of the medium, less will be the speed of light in that medium. So relation between the refractive index and speed of light. Now let's see, Azaan. Uh, this is the interface. This is suppose this is medium 1. Are you getting my voice, Azaan?
Yes, sir.
This is medium 1. Okay. This is medium 2. This is another medium 2. And light is traveling from one medium to another. This is the normal. And a light ray is coming like this and going like this. Light ray is traveling from one medium to another medium. Suppose V1 is the speed of light in medium 1. In medium 1. And suppose N1 is the refractive index of medium 1. V2 is the speed of light in medium 2. Medium 2. And N2 is the refractive index in medium 2. So the relation between the speed of light and the refractive index, when you will write, means when you will write N2 divided by N1, you will get V1 divided by V2. So this is the relation between the refractive index of two medium and the speed of light. This is also very important. And Azaan, I have told you this N2 by N1 can be written as N12. So we can write N12 is equal to V1 divided by V2. Means this N12 is known as the refractive index of medium 2 with respect to medium 1. So just write this down, all the things, and after that we will solve a numerical. That will clear your all concepts. Now write this down.
Okay, sir.
And if you have any kind of confusion in the refractive index, you can ask me right now. Azaan, do you have a book of S. Chand physics? S. Chand physics.
What, sir?
There is a book S. Chand physics.
No, sir, I don't have.
Which book of physics or science you have?
Sir, NCRT.
Only NCRT.
Yes, sir.
I will suggest you to purchase a book of S. Chand.
Okay.
But it's your choice. If you want to purchase, then purchase. I am just advising you. NCRT is the standard book that is very, no book can replace the NCRT. But the S. Chand and also known as the Lakshmi Singh and Manjeet Kaur means they are the writers. So this is one of the best reference book for 10th science. The language in this book is very easy. Written, Azaan?
Yes, sir.
This also?
Sir, can you I want to see both answer.
What?
Sir, can you scroll down a little bit more?
This one?
Yes. Yes, sir.
Fine, fine. This is the heading. Relation between the refractive index and the speed of light. Completed, Azaan?
No, sir, just 2 minutes.
Okay. Azaan, do you know what is density? Density, Density.
No, sir.
No problem.
Done, sir.
And write this also. If you have not written, then we will.
Sir, I've written.
So now we will solve one question. This question is also very easy question, and this is question from the NCERT that you have. You can check this question from that book. And this question, first read the question properly. The first thing to solve the question is to read the question properly. They are saying light enters from air into glass plate having a refractive index of 1.5. What is the speed of light in glass? They are asking. And the speed of light in vacuum they have given. I want to add one more point here before solving this numerical. Take the refractive index of air, or note, take refractive index air or vacuum is equal to 1. Okay, just learn this.
Okay, sir.
So now we will solve this question. Light enters from air into glass. Suppose here is a air. I am just drawing the rough figure. Air and here is glass. Suppose this is the normal and light is entering like this and going like this. So light is traveling from air to glass, and they are saying light enters from air into glass plate having the refractive index, and this refractive index of glass is given. Refractive index of glass is given as 1.50. And we know that refractive index of air is equal to 1. Refractive index of air is 1. And air, they have given that the speed of light in vacuum is 3 into 10 to the power 8. Also, this is also the speed of light in air. We consider air and vacuum as same medium. Speed of light in air. So speed of light in air is given as 3 into 10 to the power 8 meter per second, and we have to find speed of light in glass. Speed of light in glass. So Azaan, can you solve this question with the help of this formula?
Okay, sir, I will try.
Just try, just try. Simply you have to just put the values. You can take your time and just try to solve. If you will solve, then your knowledge will increase, your understanding will increase. I can solve this question in 5 seconds also, but you have to solve the question in the examination.
Sir, is it 2 into 10 raised to 8?
Very good, yeah. Very good, Azaan. So your answer is right. So what you have done, you have just applied this formula. N2 divided by
Yes.
N1 is equal to V1 divided by V2. N2, you can take any medium 1, any medium. Suppose this is the medium 1, this is the medium 2. So N2, you will take N2 is 1.50 and N1 you will take 1 and V1, this is V1, 3 into 10 to the power 8. And you have to find this. V2 means Vg. So you will get answer 3 into 10 to the power 8 divided by 1.5. 2 into 10 to the power 8 meter per second. Again, I already know that you are a good student, but you need to focus little bit. You will
Yes, sir.
become extraordinary. So this is the way to solve. This is medium 1. We have suppose this is medium 2. So NA means this is N1 and G means this is N2. VG means this is V2. VA means this is V1. So do you want to note it down?
Yes, sir.
Okay, just note it down. Air and vacuum treated as the same medium, but air is different, vacuum is different. But here we are treating air and vacuum as same medium. In actual, air and vacuum are different. So in the next class, I will start the lenses, refraction by lenses.
Okay.
We have almost finished this topic refractive index, and this is one of the most important topics. That's why I am giving time to this topic. Written Azaan?
Yes, sir.
So just one more question, and this question is very easy question again. In this question, refractive index of some materials or some substances like kerosene turpentine and water are 1.44, 1.47 and 1.33 respectively. And they are asking in which medium the speed of light
Sir, 1 minute. I have to go to wash.
okay.
Hello, sir. Am I audible?
Yes, Azaan. Just I have write the answer. So we know that the refractive index is inversely proportional to the speed of light in medium. So
Yes.
they are asking in which medium the speed of light is faster. So the refractive index, you have to search for the lowest refractive index, and the lowest refractive index is for water. So means lower the refractive index, higher the speed of light in a medium. Here water has the lowest refractive index, so the speed of light